I'm Doug Sillars. I'm really happy to be here. This is my first trip to the Ukraine and to Kyiv, so thank you for having me. I'm really excited to get to the city once I'm done with my talk, which will be just really, really soon. So I'm here today to talk a little bit about how I go about testing mobile applications for performance issues and how I look for optimizations to speed up apps for when your app is just a little bit too slow. So I'm Doug Sillars. I'm originally from the United States, but I've been traveling around Europe for the last 4 years as a digital nomad. I'm a freelancer. I do developer relations. I do a lot of performance stuff. So I help people speed up native apps, websites. I lead workshops on, speeding up apps and websites, optimizing images, videos. I do some machine learning and augmented reality stuff. If you're into app performance, I wrote a book on how to speed up Android apps. I'll post the slides. We'll post the slides up later. That's the PDF, so feel free to download it and have at it. It shows all the tools that I use for optimizing mobile apps, so that's pretty cool. And then if you ever just want to chat about these sorts of things, I'm easy to find. I'm the only Doug Sillars on the internet, so that makes me kind of easy to find. So let's just get started. But before we get started talking about application performance, one of the great things about traveling around Europe is I get to see a lot of really cool things. And this is a walkway that's literally nailed to the side of an Alp in Switzerland. So how many of you are a little nervous thinking about walking across a walkway that's nailed to the side of an Alp? Yeah, that's sort of terrifying. When I did this, my daughter was 6 and she jumped. It made this really nice rattling sound. It freaked out a lot of people. This has actually an important connection to performance because Ericsson about 4 years ago did a study, and they put sensors on people's heads to measure stress responses to different things. And they found that queuing up for a line raised your stress a little bit. They found that thinking about standing on the edge of a cliff stressed you out a little bit. But what's really interesting is a slow mobile app is more stressful than standing on the edge of a cliff. So that feeling you all felt like 90 seconds ago, if you have a slow mobile app, that's what your customers are feeling. And that's bad. And the reason that's bad is if you think about when you go shopping, it's always bright lights and happy music, because if you're happy, you spend more money, right? But if you're building a website or an app and people are already frustrated, they don't spend as much money, or they don't come back, right? And if our goal is to build tools and apps and websites that people come back to and spend money at, hopefully, we want to make sure that it's fast. So of course, that leads us to the next important question: what's fast? And it's a human perception. And so there have been studies on this. There's a study from the 90s that found 100 milliseconds is instantaneous. And in PowerPoint, that's 100 milliseconds, right? That feels pretty fast. 1 second, you noticed that, right? You noticed that there was a bump in between that. It doesn't interrupt your thought at all, though, right? You continued with it. 1 second's okay. But what happens with a 10-second delay? That was 10 seconds, right? Do you know how hard it is to stand in front of an audience and not say anything for 10 seconds? Right? The same thing happens with your app. You guys were yelling out answers. People using the phone are like, did I remember to turn off the stove when I left the house this morning? Did I pay the credit? Did I pay my bills, right? You get distracted if you have to wait that long. And so we lose focus in using the app. And if you've lost focus, then maybe you're not going to continue. This is interesting. This is from the 1990s, right? Does anyone remember the internet in 1993? Who used Mosaic? Oh, man. Tough crowd. All right, I remember using Mosaic. And do you remember how fast the internet was? 28.8K. You were doing well when you had a 28K modem. So a 10-second delay with a 28K modem is very different than a 10-second delay on a 4G connection, right? We've come a long way, and so this data doesn't even hold anymore. This study that came about last year found that now it's 65 milliseconds for it to seem instantaneous. And the limit for keeping focus. I think we started having people shouting out answers at about 3 to 5 seconds, right? That's when we started getting, this is taking too long. There is data on this. Google found that if a website takes over 3 seconds on mobile, you lose half your customers. Like, they're just gone. That's it. A half-second delay raises frustration, lowers engagement. 20 years ago, Amazon and Walmart found they make less money, right? That's kind of an important thing. They did that independently and came up with the same number. My favorite stat is 4% of mobile users admit to throwing their phones when there's a slow mobile experience, right? So when you see people on the bus with a broken phone, like, hopefully it's not your website or your app. So what are we going to do? Like, how do we find out if our app is slow? And some of the tools I use Charles Proxy. Does anyone use Charles Proxy? Any hands? A lot of hands. Awesome. You guys know about Charles. That's great. Anyone use Web Page Test? This is more of a web thing. A couple hands. That's awesome. And then Video Optimizer, you've probably never heard of, but I helped build that when I was at AT&T, and we'll talk a little bit about it. It's called Video Optimizer. It used to be called Application Resource Optimizer because it was all apps, but then marketing got involved and they thought video was a cooler term, so whatever. So Charles Proxy, everybody's seen that, like, I'd say 80% of everybody raised their hands, so you know what this looks like, right? Here are all the connections, here are the headers, and here's the response. The tool I helped build at AT&T back in the States is called Video Optimizer. It's very similar, it's just laid out differently. These are all the packets going back and forth. You can see the throughput, like a lot of data is going by here and here. Here are all the connections, right? We've got connections to Google, to Facebook. That IP is Facebook. We can see how many bytes, right? All of that data is there. One thing we tried to do to make it easier for app testing is we grouped all of the data that came in into different types of buckets and graded it on best practices. And so there are 40 best practices, green check marks, red X, all right, so you know where to look. So one of these, I'll just show an example. This is for resizing images for mobile. So I was testing a mobile application, and it was downloading images that were 110% larger than the actual screen of the phone, right? These images are too large. And you can see, I kind of blurred out the host name, but you can see that's 800K, 680K, 1.1 megabyte, right? These are big images. And if it's a big image, it takes longer to download, which means it takes longer for it to show up on the screen. So that's just one of those best practices. I saw a couple hands for web page test. If you're ever testing web pages for performance, this is the place to go. It's webpagetest.org. You type in the URL. You can pick locations from all around the world, so you can see how fast your web page loads in America, in Europe, in Asia, all around the world, South America, Africa, all that sort of stuff. In Virginia, they actually have real mobile devices. So you can actually, here I'm actually testing, it's not emulated, it's a G4, Motorola G4. The guy who runs its name is Pat Meenan, and this is in his basement. And so it's actually, he's got a bunch of devices down there. You can test it. And you get a result like this. So you get all sorts of scores, like how fast the page loaded. You get some grades, how much data was being used. And then you get, these are all the connections in a waterfall diagram. So there's all sorts of great information there. These are the tools that I like to use. The next thing we're going to do is we've got a bunch of tools. Now we've got a test. And so here's a person. They've got their phone. I assume they're in a corporate environment because they've got their RSA token sitting right there. This is actually just clip art that I stole off the internet. And this is great. Of course, the problem with this is when you're testing at work, you probably have really awesome Wi-Fi or a really fast connection, and you forget about your customers out in the middle of nowhere on a crappy connection, right? And these people are your customers too, and they want to make sure that the app works as well. So, you can look and see, what by country, how available 4G is and how fast it is. I forgot to see where Ukraine is on this graph, but, it's in there somewhere. The United States is like down here. But even that doesn't help you very much because this is a screenshot of my phone when I was in Ireland, right? I'm trying to go from the Cork airport to an Airbnb, and I had 4G, but I had 0 bars, right? That's not going to do me any good. All right. When I was living in Ireland for a month, I had this Airbnb that promised me high-speed Wi-Fi. What they didn't say was connected to a 3G router. that really only had edge coverage. We'll get to that, but like, people are on poor connections, and you have to think about those folks. The other thing we see here is it's a fairly new device. First off, all of the tools I just talked about, Charles Proxy, Video Optimizer, and Web Page Test, let you change the network speeds. It's a proxy. You can actually throttle the network speed. So even if you are on a fast Wi-Fi connection, you can say, let's just see what it looks like on 3G. And you can test it, and it'll work. Facebook, I don't know if they still do this, but the Facebook headquarters used to have 2G Tuesdays, and they just went to the Wi-Fi, and you had to run everything on 2G just to see what it looks like. And what's amazing is the apps work if you're really patient. You have to be really patient, but they do work. Okay, the other thing is, like, if you've got a brand new device, like we're all in tech, we probably upgrade our devices a lot more often than the average person. There's a lot of data out there that shows that, like, here's, 30% of users have a 2 to 3 year old phone, right? I mean, this is from a year ago, but I mean, people follow the same upgrade patterns, right? You can imagine that 50% of your users have a phone that's 2 years or older, right? If they have an older phone, older phones are slower, right? It's got probably an older OS on it, right? It probably has a slower processor, and this study found that websites load 20 to 50% faster every OS increase, right? So we don't want to test on the phone that's in our pocket. We need to get some devices that may actually represent what our customers have a little bit more. Does anyone here use an Android Go device? A couple hands. So here's an example of an Android Go device that got launched last year. It's called the Alcatel One X. Android Go is a huge compromise in every sense, including price. These are like 60 euros, right? They're super cheap devices. And like when you apply for a job, they always say you should turn one of your weaknesses into a strength? This review has that. It has great battery life because you want to use your phone less, right? These phones are so awful, but they're so cheap. Terrible performance, poor camera, screen would feel at home in 2011. You can buy these today. Number 4 market for Android Go is Russia. Number 2 is America, right? These are devices that are going to be used by, core markets. This is about a year ago. It was 99 euros. It's gone down since then. So we should really make sure that we're testing on slower networks, and we're testing on some of these kind of crappy phones, because that's what our customers actually have. And so then that leads us to, is it fast? So let's say you're testing an app for a car company, and you measure startup time is 6 seconds, and is that fast enough? So what you can do, and what a lot of companies do, is they say, well, let's see what the green car company and the blue car company can do. And if you're slower than your competition, then maybe you want to see if you can speed up in it, and try to beat them or match them. Maybe the blue car company has a huge budget and they launch cars on rockets out to outer space and do all sorts of cool things. You can't beat their budget. But wouldn't it be cool if you could beat that guy, right? Because that would be great. So we want to set some budgets, and some of the rules we want to look at is how to deliver the content quickly. From what I've found, most of the time an app is slow. It's stuff getting stuck on the network from the server to the device. So we want to make faster requests that are more efficient. And the biggest things we're going to be sending are probably images and videos, so let's try to make those smaller. But here's an example of an app that's starting up slowly. They've got this weird splash screen. I don't quite get it, but this is a splash screen of the app. And it took forever for it to load. You see a GET request for some JSON, all right? The phone says, hey, I support compression, right? And then the server comes back with a bunch of JSON, right? That's awesome. But here's the header response. These are all the headers that came back. And we're missing compression, and we're missing caching. And so what happens when we're missing compression? So we've got this big JSON file. The JSON file is 267 kilobytes. The phone's saying, hey, I can support compression, but it didn't get sent that way. If I just take this, put it on my computer, I gzip it, it's 42 kilobytes. Right? We're waiting for this JSON to get all the images, right? We can't download the images because the links are all in this JSON. So if there's a delay in getting this file, there's a delay on getting the images. It's just making that page load slower, right? So if we can get it down in 85% faster, that's going to be a huge improvement. If we're talking Android, Android supports the compression tool Brightly, or the compression algorithm Brightly, and that squeezes out, another 12K, so you could get it down even faster if you wanted to. So, we're gonna get this file faster, so now we can make the request for the images faster. The second thing that's missing is caching. There's no, the app isn't getting any instruction from the server how long it can store this file. Whoops, I went too far. All right, so here I am, I'm opening it up. You can see the images haven't loaded yet when I took this screenshot, right? It's still waiting on that. So this is a screenshot from Video Optimizer. I downloaded the original file at 26 seconds. It was 267 kilobytes. I read an article, and then I clicked back to this screen, but it wasn't cached. So it makes a request to the server and downloads 267 kilobytes. Then I read another article, and I go back, right? And you can see it happening over and over again. We've got an extra megabyte of downloads here. Even if they had been gzipped, we're still looking at an extra, 100 kilobytes, right? If you can just download it once and then serve it from local memory, it's gonna be a lot faster. So that should be cached. For example, here's an E tag for caching. Here's a max age saying store it for 5 minutes. I mean, that's probably the session length for this app anyway, so that's probably fine. All right, so then this all downloads and we're good. The next example, this is from a movie ticketing app. And the screenshot I took here, it's downloading all the thumbnails for what was in the theaters when I took this screenshot. And as we're waiting for this one image here to load, it's taking a long time. So why is it taking a long time? Well, it turns out that it's downloading an image that's this big to fit in a space that's that big. That's a big thumbnail. It's 470 kilobytes, right? We don't need an image that's 470 kilobytes to fit right there. If I resize it to the appropriate dimensions, it's 3, right? This is kind of a no-brainer. So if you start seeing really big images being downloaded, we can look to see if we can resize them and make them smaller, make the app faster. 99% smaller, that's a pretty big savings. So let's talk about different ways we can optimize images. So this is a picture in Portugal. The original image on my phone was, 16 megapixels, 2.2 megabytes. And one of the issues you have, if you send down a 16 megapixel image to a mobile phone, the phone gets those 16 million pixels and has to throw away 15 million of them to get it onto the screen, right? So you have to pay to download all of it, right? We've got this tax of downloading 2.3 megabytes, and then we've got this tax to get it onto the screen. So if we can minimize both of those, it's going to show up on the screen a lot faster. It's kind of like when you order a package online and you get this giant box, and then you open up the box and there's mostly nothing in it, right? All right, so in this example, I was on a 3G connection, right, with Charles Proxy. It took 14 seconds to download it on a desktop, on a Moto G4 Alcatel 1X. But look at how long it took these 3 devices to throw away those 15 million pixels. Right, 820 milliseconds. We added almost another second to getting it onto the screen, already to this really slow device that everyone hates to use, but was only 60 euros. All right, so what are we gonna do to optimize it? Well, we should resize the image on the server because we know it's a mobile device. What if we resize it to 1400 by 1050, right? Now it's 10% the original size. We could go even smaller because the Alcatel 1X has a really crappy screen, and now it's 78K. All right, there are a lot of Android devices out there, as I'm sure you all know. These are all the devices that hit Akamai. These are all Samsung devices, the big, because there are a lot of people using them. And the color of the green means it's a fast CPU, and red means it's a slow CPU. There are a lot of crappy devices out there, folks. So we need to think about that. So what sizes do we do? On the web, there's a thing called responsive images. You generate a whole bunch of different sizes, and then you serve the right one to the device. And so this is sort of how you'd build it in HTML. When I serve the right-sized image, a 1.5 million pixel image, right? So I'm throwing away 500,000 pixels right now. The download time, look, it went from 14 seconds to 3, right? So we've already sped up the arrival time of the image, but look how long it takes to decode. Instantaneous for most people, even on the slow, crappy $60, €60 phone. So we're making improvements. We're speeding up the app just by resizing the images for mobile devices. We can do other fun things like changing the image quality. So if you ever have an image that you take and you open it up in Photoshop, you can like take this slider and change the quality and it gets smaller. When you change the quality, you're removing the pixels, and so you lose resolution, so it doesn't look as good. Google recommends you save everything at 85% for the web and for apps. So if you save an image at 85%, generally from 100% to 85%, you have the size of the image in kilobytes. So it's half the size, 50% smaller. If you go too far, the image looks like crap. So we don't want to go too far because we want people to like our images. Sometimes you can go a little further than 85% with some tools that are out there. It's called structural similarity. It lowers the quality to where the human eye can't tell a difference. I've got references to how to do that in the end of the talk, so you can look at that in the slides. So it's adjusted to the limit of human perception. When I do that with this image, it was at 220 kilobytes, I shaved off another 40K. All right, so I'm getting this image smaller and smaller. It's going to download faster and faster. Again, download times were in the same ballpark with web page test. I figure an error of 100 milliseconds or 200 milliseconds is kind of normal. It's not that scientific. Other things we can do. How many of you are dealing with Android stuff? How many are iOS? How many are web? Just as a little bit of everything. That's awesome. All right, so image formats. There are a lot of modern image formats out there that you can use instead of just JPEG. I think somebody just posted on Twitter, JPEG just celebrated its 37th birthday, right? JPEG's been around a while, maybe 27th, I might be missing. Anyway, it's an older image format. But if you look out there, most of the images out there are JPEGs. We've got JPEGs without the E, and then JPEGs with the E. This is just the extension, right? And they're big. JPEGs are the largest files that are out there. This is percentile, so this is the 50th percentile is in gray in terms of size. JPEGs tend to be big. They're also the most popular, so when someone screws up an image, it's usually a JPEG, and so that's what happens. On Android, you can serve your images as WebP. WebP is a format that's about 5 or 6 years old now, and if you do browser stuff, it works in Edge, Firefox, and Chrome. Yeah, not Apple. Apple uses JPEG 2000. It's a similar format. And when you do that, you're going to get smaller images because it's a modern compression versus 37-year-old compression. And again, I save another 20 kilobytes just by changing the format to WebP. We're getting faster and faster. No one's going to notice the difference, but we're getting faster. Again, it's not an appreciable difference, but we're still using less data, which is also very important. I don't have a slide on this, but my SIM is from Ireland, and they told me that it was going to be 5 euros a megabyte while I was here in the Ukraine. So, you're generally not thinking about people who are roaming, but when people are roaming, it can be a very expensive proposition. So you want to make sure that we're not using a lot of data there. So you can see I took my original image here. I did a bunch of optimizations, and I'm way under 500K. So we're doing great there. Other formats we can play around with, SVGs. Does anyone use it as vector graphics? Vector graphics are awesome for icons. They're basically XML files that draw shapes. It's an XML file listing a bunch of shapes, and they're infinitely scalable. So if you take the Twitter icon, you can stretch it, and it looks great no matter how big you make it. Now, if you see some pixelization here, that's because PowerPoint doesn't support SVGs, so I had to take a screenshot of the SVG to put it in PowerPoint. I mentioned caching a little bit earlier. We can also cache our images. But let's go back to SVGs. I think a slide got out of order here. So I was testing a website, and I found this SVG graphic. And there was something a little bit wrong with it, so I decided to investigate a little bit further. SVG files are XML, so you can open them up in a text editor. You get some style. You can see here it's drawing a circle, and then like Adobe Illustrator, right, there's all this stuff going on. And so the reason I knew something was wrong is that it was a 900 kilobyte SVG file. And so the way you fix this is you click right there, you drag to the bottom, you delete, and then you save the file. Like, this is a really, really easy fix, and it was 1 kilobyte, right? If you see an SVG file that's like over 10K, you can do this and like just make it smaller. Of course, it's XML, so you can zip it or use Brotli and get it to like about half a kilobyte. This website also had an orange version of the same icon. And again, you can do the same thing. If you're into building on the web, you can do CSS, and you can change the red one to orange with 2 lines of code. So there's a lot of different ways we can optimize this. You can take you can do 1.8 megabytes of images. That obviously has a cost, or you can do it in like under a kilobyte, right? These are optimizations that are pretty easy to find and pretty easy to work with. Okay, so now we're going to get to caching. That slide sort of slipped out of order. This is an application. This is, again, the Science News application. There's this picture of a guy looking into his microscope. That's super awesome. I read the article, and it's a picture of the guy looking into his microscope. And you'd think, I bet they used the same image twice, because that would be smart, right? They didn't. And actually, if you look really carefully, you can see they're actually cropped differently, like the amount of space above the guy's head. And they're different sizes and different kilobytes, right? They could have gotten away with one image, 31 kilobytes, and just been done with it and used it twice. But they decided to go the 90 kilobyte route and download it all of the time. I actually found an app once that had small, medium, and large images of like album art it was a streaming music service. And every single time you requested an album, instead of downloading the small one, and then if you clicked it, you got the big one, they just downloaded all 3 every single time. Like, that's just wasting data. It made the app slow. People noticed. The last thing we can do is lazy loading. And lazy loading is something that's gotten really, really popular on the web and in apps. And so the idea is I built this web page. It's really big. It's like a 12 megabyte web page. And this is what it looks like when you load the page on your browser. When you zoom out, it looks like this. And, there's like view 1, view 2, view 3. There's like 4 different views on your desktop. And when you load this in a browser, traditionally, this is what it looked like. You got the text to load, and the images start loading, and the text keeps reflowing, right? And if you're on a slow connection, you're reading an article, and the text jumping around, it's really annoying. You can also see that if you're a user, the images up here haven't even loaded yet, but we've got a picture of a cow way down here, right? Completely useless to a user. They want this stuff up here to load first. So the idea behind lazy loading is, and the way this works in Chrome today, Chrome 76 rolled this out. They find out where all of the images are on the page right at the very beginning. And then the images load at the top of the screen first, right? This seems logical, right? It took us till 2019 to figure this out. And then the images load down the page the way we scroll, which sort of makes sense. The cow doesn't actually load until the very end. This is what's happening in Chrome. You can also do this with JavaScript libraries and all the other browsers. So that's a really cool way to speed up the way the web page loads, or in a mobile app. A lot of tools, a lot of websites are doing this. And you may notice that I have these previews. These are vector graphics. So I'm using vector graphic previews. Medium does this. You can see Google image search does this. I was searching for cats in costume. I got a green box. It became a cat dressed up like an alligator. I got a purple one. It was a cat dressed up like a princess. So these are really small. They load up 500, 200 bytes each. And then when the actual image comes, it replaces it. We've seen this in Medium, Facebook. A lot of different places do this. And then, the page loads fast. So that's kind of cool. The tool that I use to make these cool vector graphics is called Squib. It's open source, so if you guys are interested, you can use that. Other things we can do to speed up the web and apps. Who loves an animated GIF? Animated GIFs are awesome. And so this is my goat back in Seattle. This is Nora. And I made a GIF out of Nora eating a leaf. And that's awesome until you realize that the GIF is 270% larger than the movie. And so that's really bad. And the reason for that is animated GIFs are literally just like a whole bunch of GIFs that flip through at 15 frames or 30 frames a second. If you go back to 1990 and you read the spec for the GIF format, it says, we have this animated format, but nobody should use it. Like it says it in the spec. So what you should do is make it 256 colors and take out the sound. So you can remove the soundtrack from the movie and turn it into a movie. And when you make it a movie, it's 250K. That's going to load so fast on mobile. And so then, on the web, you'd say video, loop, autoplay, and muted. Even though there's no sound, you have to say muted because videos don't autoplay unless they're muted. So that, for those in the back who are bored and are reading on the web, that's why It's here so that you don't like have a loud sound coming off of your browser while I'm trying to present. So I appreciate that. The other thing that you can do is on Safari, you can actually put videos in the picture tag, which is kind of fun. But what's important from a testing perspective is the animated GIF takes 22 seconds to load, and the video takes 4 seconds to load. Like, obviously, that's a huge win. Other things that I think are really important to look at while you're testing applications is security. And so this is a screenshot. My wife was buying a plane ticket with Ryanair, and she looked at the URL field on her browser, and she noticed that it said email address equals, that was my wife's email address, and password equals, yeah, if you see that, that's bad. We're waiting for Ryanair to say, for €2 more, would you like your session to be end-to-end encrypted? Right? There's a lot of tools that will help you look to see if there is data leaking out of your application. This one especially looks at like the third-party analytics. He found that the apps he was using was leaking both his last name and the booking code out to third parties. And what do you need to check into your flight? Your last name and your booking code, right? So you should be careful about that sort of stuff. The stuff that I've seen passwords, I've seen like medical stuff leaking out this way, like really scary stuff. We should be really careful. And then, we're close to running out of time, but we can also look to see there's other ways we can optimize. And one thing that's cool is there's a tool, there's light mode in Android and Chrome. It used to be called data saver mode. It adds a header that says, send less stuff to me. And so this header goes to the server and says, I want less stuff. iOS, I'm hitting the wrong button again. iOS 13 has a low data mode. So you can actually make your app use less data if the people are asking for less data. So serve less data if your customers are asking for it. The save data header, this is from October of last year, but 5% of his users have this turned on. If 5% of your customers are saying, send me less stuff, maybe serve them the next smaller image, maybe turn off videos, maybe don't animate the GIFs right away. You could imagine like the BBC webpage, you could just remove a row of the images and it would be a smaller webpage. Tools like Cloudinary, which is a cloud-based image optimization tool, so you can do all of the optimizations I was talking about with images. If you set it to automatically scale the quality, the image is 180 kilobytes. If it sees this header, it changes it to a bit more aggressive and saves another 45 kilobytes, just making that image a little bit smaller. There's also the Network Info API. And what this is it's actually some JavaScript in the browser, and it's also in Android as well, and it'll tell you how fast the network connection is. So that's that month when I was in Ireland, and I was on this really, really slow 2G connection. Whenever I fired up Twitter or Facebook, the videos didn't show up, the animated GIFs didn't play, none of that stuff happened. When I went into the city and fired up my phone again, the videos played, the animated GIFs played. These apps are looking at my network speed, because if I get frustrated using Facebook or Twitter, I may stop using Facebook and Twitter. So they hide the stuff that won't work when you're on a slow connection and then show it to me later when I have a fast connection. So that's a trick that you can use to make sure that the app looks great when your customers are in a place where they might have not such great coverage. Something to think about. And as you're testing and looking at performance things, you may get your app or your website as fast as your competitors. But we all know that over time, we're going to add more stuff to our app and to our web page, and it's going to slow down again. So you have to keep looking every single time new code is being added to the app that you're not slowing it down, or if you are slowing it down, is it an acceptable slowdown? Speed Curve is a tool for the web. It monitors different load times every single day, right? So you can see if there's been a change. There's similar tools out there for apps, so you can look at that as well. So you can test over time, how fast is your app, how fast is your website, are you slowing down? So the tools I used Web Page Test and the HTTP Archive to get a lot of the data on how fast the web is today. Image Magic, structural similarity, lazy sizes. Lazy sizes is a JavaScript library to do lazy loading. Responsive breakpoints to resize the images. Cloudinary is a great cloud-based image hosting, video hosting service to help you resize all your images and your videos so that they're fast. And it does a lot of it magically, so you don't have to worry about it. So in conclusion, images and video and apps, they can all be beautiful and fast. You just have to work on it a little bit to make sure that they are. And you have to test and constantly be vigilant to look for it. So thanks so much for listening. I appreciate you all coming out.
Yeah, so it's time for questions. Just raise your hand.
Yeah.
Thanks for your speech. What about tooling for measuring performance of Android and iOS app in meaning of native apps?
So measuring the native apps. So I think there are a couple ways. One is your analytics has some of that, right? I'm sure you've got analytics in your app. So there's two ways. One is this is sort of synthetic testing, where it's in like a laboratory environment, but you also have your analytics. And in your analytics, it'll tell you how fast different views are loading, or you can set it up to show that. So you can see, what your customers are actually seeing, which is actually useful. And a lot of people like to look at the 90th percentile to make sure that the user experience is good for 90% of your customers.
Thank you.
Yeah.
More questions? If no, so thank you very much.
Thank you. I'll be around if you want to chat afterwards too. Thank you.